Welcome back to my channel. Our topic for today is the integral yielding inverse trigonometric functions. Okay, so we have here presented the different derivative formulas of the trigonometric functions or the inverse trigonometric functions. We have inverse sine u, inverse tangent u, inverse secant u, inverse cosine u, inverse cotangent u, inverse cosecant u. Now we have the following results right here. Okay, so we are already familiar and we have memorized this one long time ago. So our task is to find the formula for the integral. Okay, so this time we will focus our attention to these three inverse trigonometric functions. We will only focus on sine, tangent, and secant. We will no longer memorize cosine, cotangent, and cosecant. Why? Because as you can see, they have the same formula, they differ only in sign. They have the same structure, they differ only on sign. These two also the same, almost the same, but they differ with this negative. So we will only focus on these formulas. Let's erase this one. So we all know that the integral is the reverse of the differential. So taking the integral of this one, the integral of du over the square root of 1 minus u squared, that is resulting to, okay, we have the arc sine u plus c. Now if we take the integral of this one, we will be having a result right here. The integral of du all over with 1 plus u squared, that is equivalent to the arc tangent u plus c. And here, taking the integral of this one, integral of du over u squared of u squared minus 1, that is equivalent to the arc sec u plus c. Now these are the formulas that we will be needing here at yielding inverse trigonometric functions. So these formulas, as you can see, they are just inverse of this derivative. Okay, so aside from this formula, if we've seen this one from our integrand, so we will immediately find its corresponding result. So aside from this, we will be having another set of formulas. This one, given the situation that we have a constant one here, a constant one, a constant one. What would happen if given in the problem this is no longer 1? Okay, so we have an additional formula. So the additional formula is, okay, the integral of du over the square root of a squared minus u squared. So it is no longer 1. It is now a squared. This could be any constant, 3, 15, 25 raised to squared. So still resulting to the arc sine. This time it's u over a here. This is u over imaginary 1. And we also have integral of du over a squared plus u squared. From this point right here, this is no longer 1. This is now a squared. So we have 1 over a, the arctan of u over a. So if this is 1 in this equation, or in this formula, we have 1 over 1. This would still be 1 all over 1. So we would still have the same. So 1 over a, the arctan of u over a plus c. And the last one, the integral of du over u squared of u squared minus a squared. Here it is 1, so resulting to 1 over a. In this formula we have 1 over 1, so that is just equivalent to 1. The arcsec of u over a, so this is again with u over 1 plus c. So we will be using this formula if our a is not equivalent to 1, and we will use this formula if our a is equivalent to 1. Okay, please observe the formulas that we will be using here at inverse or yielding to inverse trigonometric functions. Let's have examples. Okay, let's evaluate example number 1, the integral of dx over the square root of 4 minus 9x squared. Okay, so what shall we do? We already have the formula. Okay, so this one is found in the arcsine formula. A du in the numerator, so we will be finding a squared and then u squared. So solving this one, we have to find a squared and the u squared. The a squared is the 4, while the u squared minus the u squared is obviously 9x squared. So we need to find u and a, so that we will be substituting it here. So what is a? The square root of 4 is 2. What is u? The square root of 9x squared, that is 3x. What is the derivative of the u? The derivative of 3x, that is 3dx. Okay, so let's try to check in our original integrand. We have a squared, we have u squared. This is not the derivative of u. We need 3. So we will correct this one with 3 over 3 integral of dx over the square root of 4 minus 9x squared. We will write the numerator 3 inside. So this is now 1/3. 1/3. What is 3dx? 3dx is du over with the square root of 4, that is our a squared, minus 9x squared, it's our u squared. So what is du all over with the square root of a squared minus u squared, that is equivalent to the arcsine of u over a. So we have 1/3 the arcsine of u over a plus c. Or we shall have 1/3 the arcsine. The u is declared already, 3x, while the a is 2 plus c. This will be our final answer. Okay. Now let's solve for number 2. We have gx over 3x squared minus 2x plus 5. Okay, so the integral of dx over 3x squared minus 2x plus 5. Apparently, we have negative 2x. So if you look at our formula, notice it should be u squared and a constant. U squared and our constant squared. So here we have the u, 3x squared, and we have the constant 5. We have now the combination of the two. So meaning to say, we have to do something first. Maybe we could factor this one in order to have an example just like this one. Notice there's no square root, so we will not focus on sign. There's no square root, so we will also not focus on secant. We will focus our attention to to tangent. Okay. So notice we could do an algebra to this one if we recall completing the square. Okay. But this time in completing the square, we have to make sure that the coefficient of x squared should be 1. So if we have x squared, 3x squared minus 2x plus 5, if we factor out, if we divide everything with 3, so times 1/3 times 1/3, just like with this one. So this will be divided with 3, right? This will now become x squared minus 2 over 3x plus 5 over 3. Okay, now we can complete this one. How to complete? Our technique is finding px. X squared plus px plus a constant. What shall we do? We divide this with 2, p over 2, and then square this one, and it will be and it will be added in our original equation. Okay, so we will be having x squared plus px. The square is p to the 2, or p squared over 4 minus, or let's have plus c minus p squared over 4 to complete, and to have x plus p over 2 squared, and we have c minus p squared over 4. So we'll use this technique completing the square. Now this is equivalent to dx. We have x squared minus 2/3 x plus 5 over 3. So our p here is obviously 2/3. 2/3 divided by 2, that is 1/3. 1/3 squared, that is 1 over 9. So we now have dx over x squared minus 2/3 x plus, let's add 1 over 9 plus 5/3 minus 1 over 9. Okay, so let's begin. So we have right here dx over this one can be factored with x minus 1/3 squared. Okay, how about this one? So 5/3 minus 1 over 9, that is equivalent to 14 over 9. Okay, so we begin by finding out what is the a squared and what is the u squared. The a squared is obviously 14 over 9. This is our constant, and this one, this will be our u squared. X minus 1/3 squared. The a, the square root of 14 over 9, so that is square root of 14 over 3. How about the u? Taking the square root, x minus 1/3. How about the du? That is dx. Okay, so let's have a space right here. Okay, so we now have dx as du. X minus 1/3 cubed, that is equivalent to u squared, plus this one, this is equivalent to a squared. So du over a squared plus u squared, so we could interchange this one because this is just plus, that is equivalent to 1 over a, the arctan of u over a plus c. Okay, what is a? 1 over the square root of 14 over 3, the arctan of the u. The u is x minus 1/3 over the a is square root of 14 over 3. Take the reciprocal, 3 over the square root of 14, the arctan of, simplify the numerator, 3x minus 1 over 3, all over with the denominator square root of 14 over 3. Let's see, we could cancel 3. Our final answer will be over the square root of 14, the arctan of 3x minus 1 over the square root of 14 plus c. Now this is our final answer. Problem number 2. Okay. Now let's solve number 3, the integral of 2x plus 7 times dx whole over with x squared plus 2x plus 5. So what are we going to do with this one? First, notice that most of our formula, the numerator will just be du, du, du. Okay. So if we happen to look at here, this could be du in some way, but we will be having an algebraic term first. We have 2x plus 7. There must be a direct relationship with this one and the denominator. If we're going to derive the denominator, if we consider that one as u, judging from the previous topic that what we have, if we have u as x squared plus 2x plus 5, deriving that one, that will be 2x plus 2 dx, x squared, so 2x plus 2, and all are multiplied to dx. If you look at the numerator side, we have 2x, 2x. 2 could be derived out from 7, right? If we separate 2 and 5. So we would have integral of 2x plus 2 plus 5 all over with x squared plus 2x plus 5 d of x. We could group this one and separate plus 5. Okay. So we would have 2x plus 2 all over with x squared plus 2x plus 5. And we have plus 5 over x squared plus 2x plus 5. This is still part of our integral and our dx. Now we could split this one. Integral of 2x plus 2 over x squared plus 2x plus 5 dx plus 5 is the constant, dx over with x squared plus 2x plus 5. This one has a direct relationship. As this is the u, then this is the du, right? So if we have u, the denominator, x squared plus 2x plus 5, the du is 2x plus 2 dx. So this is now the form of du over u, the ln u. Let's pause for a while for this integral. How about this one? Let's focus our attention here. We have 5 integral of dx over x squared plus 2x plus 5. This could be part of the inverse since we have dx only in the numerator. roots of it here. We have 5 integral of dx over x squared plus 2x plus 5. Now, if we complete again the square of the denominator, completing the square. Now, if we complete the square of the denominator, we begin to see another inverse tangent formula. Okay, so if we have x squared plus, this is our px, p divided by 2, that is 1 squared. So we will be adding 1 and we will be subtracting 1. Now notice we could now factor this one. So 5 integral of dx whole over with, the factor of this one is x plus 1 squared plus the result of 5 minus 1, that is 4. We can now obviously what is the a squared and what is the u squared. The a squared is 4, then the a will be 2. The u squared is x plus 1 squared. The u is x plus 1. The derivative of the u is dx, found in our numerator. Okay, so we begin to have 5 integral of dx is du over with this one, it's the u squared plus the a squared. Okay, so the integral of du over a squared plus u squared, that is 1 over a, arctan of u over a. So this is 5 and we have 1 over a, 1 over 2, the arctan of u over a, x plus 1 over 2. Okay, now here, this is our result in this. We will multiply by the 5. Yeah. So this will now become 5 over 2, the arctan of x plus 1 over 2. How about here we have ln u, du over u, so this is ln u. What is our u? So this is ln of x squared plus 2x plus 5 plus, the result here is this one, 5 over 2, the arctan of x plus 1 over 2 plus c. This will be our final answer. Now let's solve number 4. The integral of 6 dx over with quantity 2 minus x multiplied to the square root of x squared minus 4x plus 3. Again, if we look at our integrand, we have negative 4x. Okay, we wish that this one has the u squared and this one has the a squared, but what is the purpose of this one? So again, we will be completing this one, or we will do completing the square. And notice we have a square root and we have a quantity outside, then that must be part of the second formula. U outside, the u squared is inside. So completing this one up, let's have 6 dx over 2 minus x, the square root of, we have x squared minus 4x, this is our px, 4 divided by 2, that is 2, 2 squared, that is 4. So we're gonna add 4 and we're going to subtract 4. Okay, now let's try to factor. We have 2 minus x, the square root of, how about this one? So as you can see, we can factor this one with x minus 2 squared, 3 minus 4, that is negative 1. Okay, so we could write 6 outside the dx in the numerator. Notice 2 minus x, and here we have x minus 2. So it should be the same quantity. So it should be the same terms. So we will be factoring out negative. So this will now become negative 6. This will be reverse x minus 2. The square root of x minus 2 squared minus 1. Obviously, we have our a squared as 1. Our a will be 1. How about here? Our u squared, that is x minus 2 squared. Our u is x minus 2. Du is dx. So let's have negative 6. The integral of dx is du. X minus 2, that is the u. The square root of u squared minus a squared. This is 1 over a, since we have a 1. So this will just be 6. We have 1 over a. The arc sec of u over a. And our plus c, of course. Let's have negative 6. A is 1. 1 over 1, that is just 1. Arc sec of the u, x minus 2. Divided by 1, that is just x minus 2. Plus our constant c. Now this will be our final answer. Now let's have another example, number 5, dx over the square root of 1 minus 4x squared. We can now obviously assign values of the a squared and u squared. Since this is just two terms, the a squared is obviously 1, therefore a is 1. The u squared is 4x squared, and the u will be 2x. How about the du? The derivative of 2x is 2 dx. We will be needing 2 here. Correcting this one by multiplying 2 over 2, the integral of dx whole over with the square root of 1 minus 4x squared. Writing this one inside and replacing it with 1. We now have 1 half 2 dx, that is du, over the square root of a squared minus this one, it's the u squared. So this is the arc sine. The arc sine of the u plus c. Okay, over a, that is just 1. Just let's write 1 u over a. So the answer will be 1 half the arc sine, what is the u again? 2x over 1 plus c. Number 6, our last item, integral of ds over the square root of 2s minus s squared. Okay, in this example, we can if we consider this one as the u squared, this one is obviously not a constant, so this is not an a squared. So we will be again completing this one. So if we factor the negative, so we could reverse this one, s squared minus 2s. Okay, so let's have ds. Okay, so let's complete s squared minus 2s negative. Let's have 2 divided by 2, that is 1. 1 squared, that is again 1. So we'll be adding 1 and subtracting 1. Okay. Now we can factor this one. Square root of this one, it's s minus 1 squared minus 1. If we distribute the negative, es over the square root of this one will become negative, this one will become positive. 1 minus s minus 1 squared. Okay. So we could now assign values of the a squared, which is 1. A is 1. How about the u squared? S minus 1 squared, the u is s minus 1. The derivative of u is ds. Okay, so we could obviously see that the integral of ds is du over the square root of 1 minus the u squared, or a squared minus u squared. Okay, the square root of a squared minus u squared, that is again equivalent to the arc sine of u over a. Let's see. The arc sine, what is our u? S minus 1. Since our a is just 1 plus c. This will be our final answer.